BMIS 270, Part 3. Excuse me. And then what we'll take a look at with this particular video is really specifically charts and understanding charts. So in this first one, we're looking at economic feasibility, and we're performing a cost-benefit analysis. Now, in this particular example, the first year of a project, and this is the cost category, these are the benefits at the bottom. So for hardware, you're spending, like $30,000 in hardware, $30,000 in software, and $10,000 in personnel. Zero in maintenance because you're just installing the system, you're not actually maintaining it. And then so all of these added to be $70,000. So what you have to do then is add the, well, let me step back. In year 2, you have personnel costs at $12,000, maintenance at $2,000. Year 3, personnel costs at $14,000, maintenance $3,000, and then so on and so on. You see this personnel cost continues to rise. Typically, as any system becomes a little more antiquated, and generally speaking, so typically, your personnel costs will continue to rise, and your maintenance costs will continue to rise until that system is antiquated enough or beyond its useful lifespan. So your cost at year end, big cost at the beginning, but then you have 2417. That should be actually what is that? 16, 17, 20, and 23. So this should be actually 88. So the initial cost, the cumulative cost at this year's end is 70,000. But for the cost of the entire system, and remember there's an $8,000 difference here, that you actually have 70 plus 16, which should be 86. And then that's cumulative. So you have to add up how much the lifespan of this system is going to cost. This would be minus the 8, 103, minus the 8, what is that, 123, and then 146. So this system is going to cost $146,000. $146,000 over a 5-year lifespan. Now the benefits, though, the first year that we'll see from finished reports, $15,000 savings or benefit over those 5 years. But an increase in sales, 25 to 35 to 45, 55, and 65. So we see increased sales. We then have to show the benefits at the end of the year, okay, which will be those per year, and then cumulative benefits we'll have to add up here. So what we really see, based on the cost-benefit analysis, the proposed system will be $146,000 greater. The benefits of the proposed system will be $146,000 greater than the cost over a 5-year time frame. Remember, there's an $8,000 difference. That's so that should end up being $154,000. These are just pictures out of the book. So I won't change this number here. So we can see that over a 5-year time frame that the benefits will exceed the costs. And is the project then worthwhile? Well, probably so. This chart presents costs and benefits of 2 possible project alternatives. So we're looking at project A and we're comparing them. It's the same picture, years 0 through 6. The costs of the project, the cumulative costs of those are added. So in year 3, year 0 and year 1 project costs are added together, and so on. The benefits, that lays out the same, so that we can see the cumulative benefits being $213,000. Year 0 is typically that maintenance year. In this example, we see that, or that development, installation year, implementation year. We see in this example year 1 being that implementation year. In this example, project A, we see year 0 as being that implementation time frame. Now, so here's project B, and it lays out a little bit differently. So it lays out differently only in that the costs and benefits are a little bit different. There is no benefit in that first implementation year, but moving on further, what we're seeing here, and I'm finding it hard to see because it's kind of small on the screen, we see costs of 40, 25, 22, 24, 26, and 30. That is a little bit different here. So our cumulative costs are greater overall 247 to 181. But the particular benefits, though, we see the cumulative benefit, or the benefits at 39 to 42 in those last couple of years. In this particular project, we see benefits of 70, 82, and 92, with the cumulative benefits of 330. So if we subtract A181 from 213, what is our net income over those 5 years, or 5 years actually, 1 through 6 years. I'm sorry, 6 years, 1 through 6. Now that's versus 330 minus 247. So that would be about 83,000 as a net profit over these in Project B. Okay, and again that was 83,000. The net profit on this particular project, Project A, it'd be 19 and 13, which would make 32. So we're looking at 80,000, 83,000 versus 32,000. So just from a simple financial analysis, we would go with Project B. Now take a look at the numbers, and I hope that makes sense. But we are comparing two projects, different costs, different benefits. What's the cumulative cost versus the cumulative benefits, and is it worth the money? Okay, next slide is also economic feasibility. Now this looks a little weird, but if you look at that, it can make sense. This is the processing costs. This is the units of production. So this is the old system, okay, the current system. So right now, whenever you produce 60,000 units, it costs you, what is it, about $3,800, $3,600 per unit to cost, or unit to develop. Okay, now at 70 is about $4,000. Okay, and at 80 it's more expensive, and 90 more expensive. Now this is the development of a new system. So this is the comparison of the old system versus the new system. Now the new system costs so much money. That's this line. Okay, and these are fixed costs of that new system. So what we're seeing here is there's a break-even point at 70,000 units. Now what that means is that if I'm going to develop this new system, and if I only intend to build 30,000 units, my processing volume is only at 30,000 units, well, then I don't really make any money. Okay, at 70,000 units is my break-even point, and anything above that is costing me less per unit. If we look to the left, it's costing me less per unit to manufacture with the new system than with the old system. Okay, take a look at that one as well. That makes sense at the break-even point. I'm not sure if I explained that well enough, but the point is, once again, that after a certain amount of processing volume, there's a break-even point. Beyond that break-even point, it makes sense to it costs you less to actually produce this particular stuff with the new system than the old, even though you have a certain amount of cost associated with developing that and implementing that new system. Okay, so if I intend to grow, if I intend to produce more, this new system makes sense. If I'm going to scale back the production on a particular item, it doesn't make sense. That's the point. All right, break even for one system. Now this really goes back to what you're going to see in the assignment. Okay, we're doing a cost-benefit analysis. So we're looking at cumulative benefits of year 0. There's no benefit. Okay, year 1, 6,000, 3286, and so on to 330,000. Now these are the costs. This is the big implementation cost. But this is the cumulative costs. 120, so it's 40,000 plus 80 is 120, and so on and so on, so that we can see what the benefit is going to be versus the cost. And we see our break-even point is at about 4.5 years, I guess that would be. Year 0, 1, 2, 3, 4, about 4 years. So over a 5-year time frame, is this project worthwhile? I don't know. Maybe, maybe not. The next slide. It's the same kind of thing, but now we're going to compare the old system, the current system, with the new system. So what we're looking at then is benefits and total costs, and then the fixed and variable costs actually make up the total costs. So the new system will be netting $62,000 per year at year 6, and we can see that here. The current system, there isn't that big implementation cost of the new system, the new fixed costs of the new system. There are some, but not that much. And then this is using the old system, so the benefits are adding up, or the benefits, I should say, are here. The costs are here, this line, and of course the costs are the fixed plus variable costs. So that we see a declining, and this is typical, we see a declining benefit from the old system. As it ages, it just becomes less useful. So with the new system, it's going to cost us $80,000 to implement, but where is our break-even point? So the current system is declining in revenue and benefit. The new system is shooting up like this, so our break-even point is a shade over 2 years. So if we implement the new system, that we should be making money above the old system, the current system, I should say, at the point 2 years and some months. Does that make sense? Over a 5-year time frame, it probably does. Okay, now return on investment is simply how much money do you put into a particular project versus how much you get out of it. So benefits over a 6-year period, and that's cumulative benefits, $92,000. Costs, that's not cumulative costs actually. It has to be, you have to, in this picture it's not cumulative. In your formula it's total benefits minus total costs over total costs. So we would add all these numbers up, and the return on investment over 5 years is 9.43. So at this point, from year 0 to year 5, the return on investment is only 9.43. That year 6 is the big year that actually creates a lot of income for us. So return on investment over 6 years is at 33%. That's at this point. So if does that system only work for 7 years? Where are you at with the lifespan of this particular system? Okay, return on investment. The next piece is net present value. So what you're doing, net present value is the present value of a future dollar and is used to determine what an investment made some years down the road is worth today. So if I were to invest $1,000 at 6% interest, what is that money worth in 5 years? That would be worth somewhere along the lines of $1,800, $1,900, $1,800 probably at 6%. So in theory, any project with a positive NPV is economically feasible, and then you can also use the NPV to compare these projects. Now the discount rate is the interest rate used to determine the present value of future cash flows. If we have high inflation, that discount rate will have to change dramatically from what it is today. Now, so for instance, how much money do I invest today, assuming an interest rate of 10%, if I want that amount of money to be worth $10,000 in 5 years? Okay, so you determine this by going to the discount value table right over here. Find the value that interacts with 5 periods and 10%. So 5 periods at, where is it at? 10%, 0.621. And then that number, and then multiply 10,000 times 621, so that it would be $6,200 and $6,210. So I would, at 10%, in order to get to a point of a 10,000, I have to invest $6,200 today to get there. So that's kind of how this works, and that's the idea behind this. Go ahead and read the rest of this to understand the benefit table. Look at year 1. Okay, I think we've got that. We explained that. So here's another example also. Now, let me go on. That net present value is a little difficult to understand. We can look at the net present value of one particular project. In this case, we're using a factor of 12%, which would be over 6 years. Go back to this table, 12%. These are the discount values, or discount rates associated with 12%. So if we look at that over so many years, we factor in what our benefits are expected to be. That factor is something less. For instance, if we wanted to get to $92,000 in year 6, we would have to invest somewhere around $42,000 today to actually make it worth that. That's a discount of 0.507%. That's probably not exactly right, is it? It'd be more like 46,000. Okay, the present value is 46,644 plus all these numbers. It's 202,186. Okay, now the costs, you do the same thing with the costs, and you can factor those out at 12%, and then so the present value of the costs are all these numbers associated together. So our NPV of cost is 116,808. Now that leaves our net NPV for this particular project at 80. The benefits subtract the costs, so the NPV is $85,377 today. Now, it doesn't really tell you a lot for one single project, but if you go out here and do that with multiple projects, you can compare the NPV today, one project versus another project, and whatever project provides you the greatest NPV, then that's a reason to go with that project. So the financial analysis piece of this is really important because it goes back to the fact, why would you do a project if you're not going to make money? How can you determine if you think you're going to make money? Well, by doing these cost-benefit analysis, comparing one system, old system to a new system. That's the old system to a new system. By looking at your return on investment, by looking at your net present value analysis, and using this kind of a model, this kind of a picture to determine, and using not just one project but two projects, and you compare two projects in the assignment. Which has the greater net present value? The one with the greater net present value is the one I want to go with, probably, because I'll probably make more money in the end. So that was kind of a little difficult to explain like this in this video format. Hopefully it'll make sense, and I'll probably try to add a short video about the assignment itself, kind of like I have with the project management piece. So we've looked at the SWOT analysis, we've looked at tangible, intangible, direct and indirect costs, benefits, also economic feasibility, cost-benefit analysis, ROI and NPV, and the present value analysis adjusts the value. Remember that the present value analysis adjusts the value of future costs and benefits, and this accounts for the time value of money. And then, although we didn't address total cost of ownership, that is the cost of, say you have a computer lab, or like at Helena College, what is the cost of the hardware, the software, the maintenance over the total lifespan of that particular lab as is. So, so that kind of summarizes all of what we'll cover in Chapter 8. Thank you.